All right, good day. Hope that you're doing good. So in this video, we're going to be looking at the similarity theorem, right? So we're going to be looking at question 9, which is from a previous exam question. Now it says, in the diagram, triangle ABC and DEF are drawn such that angle A, right, is equals to angle D, angle B is equals to angle E, as well as angle C is equals to angle F. Basically, these two triangles have equal angles, right? Now we need to prove the theorem which states that if two triangles are equiangular, then the corresponding sides are in proportion, right? Basically, this is what we are required to prove. Now, first, to prove this, I'm going to start by my construction. Right. So I'm going to use the bigger triangle, triangle ABC. Right. Now, under my construction, I would construct, so I'm going to draw line ZK, right? Such that, so this is my line ZK, such that AK, which is this line from A to K, is equals to DF, and AZ is equals to DE. So this is the most important step. So we're going to draw this line ZK such that this side AK is equals to DF and the side AZ is equals to DE. Now, what is the next step? So the next step is that we're going to try and prove, right? So let me just write that down. So now we're doing the proof. So basically here, we're going to try and prove, right, that triangle DEF, it's congruent, right? Or exactly the same to triangle AZK. Basically, we're going to prove that, we're going to try and prove that this triangle right over here we have drawn on the bigger triangle, right? It's exactly the same as this smaller triangle. Now, I'm going to say, now I'm doing my proof, and I'm going to name my triangles in triangle DEF and triangle AZK. So first, I state my two triangles in which I'm trying to prove that they are congruent to one another. So now, let's start with proving that these two triangles are congruent to one another. First, can you see that here I'm given angle D? Right? And we said this angle D is equals to the angle A in the bigger triangle, right? Which is here. So I'm going to say, okay, angle A is equals to angle D. And this was given. Right? This is the first thing that we've proved in these two triangles, that they are equal. Now, the second thing, I'm going to say, all right, my line AZ, which is this line from A to Z. So AZ, this line is equals to DE. And I've mentioned that in my construction, whereby I said I'm going to draw a line ZK such that AZ is equals to DE in this case, right? So my reason is going to be construction. Now, last thing, I'm going to do the same for the other side. I'm going to say this side AK, so AK, it's equals to DF. And remember, I've also mentioned this in my construction, and my reason is going to be construction. Right. Now, therefore, I can conclude that these two triangles, triangle DEF as well as triangle AZK, they are exactly the same, or they are congruent to one another, right? Now here, my conclusion would be, therefore, triangle DEF, it's congruent to triangle AZK. Now remember, the manner in which you arrange your alphabet, it matters. So if here you say D, E, F, if you move in this pattern, also on the other triangle, you need to do the same. You need to move from A to Z to K. Hence here I did this, right? And what would be our reason here? So we prove that two sides are equal as well as an angle. Our reason would be side, angle, side. All right. Now that we have proved that DEF, it's exactly the same as this triangle we have drawn here on the bigger triangle, which is triangle AZK, right? Now, second thing, or rather the last step we need to do is that we need to prove that this line, right over here, let me use a different marker. We need to prove that this line is parallel to that line, right? So if we can prove that these two lines are parallel to one another, therefore we can use ratios in this triangle, all right? Now, let us go about doing that. Now, remember, there are only three ways you can prove that lines are parallel to one another using this fan shape. So if you could prove that this angle is equals to that angle here, therefore these two lines would be parallel to one another, right? And here, if you could prove that this, when you add these two interior angles, they equals to 180. Therefore, these two lines would be parallel to one another. And in this case, if you could prove that this angle right over here is equals to that angle there, therefore these two lines would be parallel to one another. Now, in this case, I am trying to use the F shape, right? So let me highlight it so that you could see it. So remember, I'm trying to prove that line ZK is parallel to line BC so that I could use ratios, right? Now, if I could prove that this angle right over here is equals to that angle right over there, therefore, these two lines, which is ZK as well as BC, they would be parallel to one another, right? And our reason, it would be corresponding angles, meaning that we would make use of the F shape. Right, now, let us go about doing that. So first, we're going to start by mentioning that our angle Z, right, is equals to the angle E, which is in the other triangle. And the reason was that these two triangles, we said they are exactly the same. Triangle DEF is congruent to triangle AZK. This is the first thing. Now, remember, we said before, right? We said that angle E is equals to angle B, right? And this was given. We were given this information, as you could see, they indicated with a star, both of them, right? So therefore, this simply means that also angle Z, it will be equals to angle B, which is what we're trying to prove. Remember, we're trying to prove that this angle Z is equals to this angle here, which is B, right? Therefore, angle Z is also equals to angle B. Because why? Remember, I said my angle Z is equals to E, and I've stated the reason for that, right? So now I've proved that these two angles are equal to one another. Therefore, I can conclude that the two lines would be parallel to one another. So let me write that down. So here, therefore, ZK, line ZK, it will be parallel to line BC. All right. Now, because these two lines are parallel to one another, okay, first here, let me write my reason. My reason here would be corresponding angles. Now, because these two lines, they are parallel to one another, therefore I can use ratios, right, in accordance to the proportionality theorem. So now, remember, I was trying to prove that, right, let me try and use this ratio, AB over DE, let me write it here, AB over DE, it's equals to AC over DF. So as you could see that AB is the long line, right? So here's my A to B. So I'm simply going to write, so I'm allowed to use ratios in this case. Because why? Line ZK is parallel to line BC. Now I'm going to say AB over, so now I'm going to say AZ, because why? AZ, it's exactly the same as my DE, is equals to AC over AK, right? And what would be my reason? Proportionality. And I'm going to mention my parallel lines. ZK, it's parallel to BC inside triangle ABC, right? So, and lastly, we are approaching the final stages. I'm going to say, okay, but remember, I said that my AZ is equals to DE, and I also stated that my AK is equals to DF. And why is that? Because these two triangles, AZK, as well as triangle DEF, they are congruent to one another, meaning that they are exactly the same, right? And my reason would be triangle AZK it's congruent to triangle DEF. Right. Therefore, where I see AZ, I can substitute DE, and also where I see AK, I can substitute DF. Right, let me go about doing that. So therefore, this is the same thing as AB over DE. It's equals to AC over DF, which is what we were required to prove initially, right? And this would be your final answer.